Hello students, this is Rajeshwar Rao Mankala, working as lecturer in physics at SVLNS Government Degree College, Bhimanipatnam. So in the present class, I am going to discuss about the interference of light. This is in semester 2, paper 2 of BSc MPC students. The title of the paper is Wave Optics and the unit 1 is Interference of Light. So in the present class, I am going to discuss about what is interference and what are the different methods to observe interference pattern and how to get coherent sources and what are the different procedures to get coherent sources. So let us discuss. Okay. The objective of this class, the objectives of this class are to understand the concept of interference of light. First of all, we have to know what is meant by principle of superposition of waves. What is principle of superposition of waves? We have to understand that concept. What are monochromatic waves? And what is coherence? How to get coherent sources? To get these type of coherent force sources, what are the different methods that we have to follow? What is meant by division of wavefront and what is division of amplitude? So these are some of the topics that we are going to learn in the present class. So let us discuss the first topic, that is principle of superposition of waves. So this is superposition theorem. As we know, when a wave is traversed through a medium, the particles of the medium displaces and they execute simple harmonic motion about the mean position or the equilibrium position. So whenever a wave propagates through a medium, the particles of the medium vibrates. Then principle of superposition states that if a medium, if more than one wave, that is two or more waves, are traveling through a medium, then each and every particle is displaced by these waves. Then what is the resultant displacement of a particular particle due to these waves? In order to get the expression for the resultant displacement or amplitude or the resultant intensity, because the intensity of a wave is proportional to its amplitude, square of the amplitude. So intensity depends on amplitude, or intensity is proportional to square of the amplitude. So this principle states that the resultant displacement of a particle of the medium acted upon by two or more waves simultaneously is the algebraic sum of the displacements of the same particle due to individual waves in the absence of others. That is, if a wave is propagating through the medium, then the particles of the medium vibrate. Now consider only single wave, only one wave. Remaining all waves are absent. So when only one wave is propagating through the medium, the displacement of a particular particle at a particular instant of time is y1. Y1 is displacement produced in the particle due to first wave in the absence of others at a particular instant of time at a particular place. Now consider the second wave is propagating through the same medium. Now the first wave is absent. When second wave is propagating through the medium, then the displacement produced in the same particle by the second wave is y2. So when first wave is propagating through the medium, the displacement is y1. The second wave is propagating through the medium, the displacement produced in the particle is y2. Then the resultant displacement of the particle due to if the two waves are acting at same time. If the particle is acted upon by two waves at same time, then the resultant displacement is given by r is y1 plus y2 when the displacements are in same direction, and r is y1 minus y2 when the displacements are in opposite direction. Because displacement is a vector, so if the wave lifts the particle in upward direction, and the second wave also lift the particle in upward direction, then resultant displacement is y1 plus y2. If the first wave lifts the particle in upward direction and the displacement produced due to second wave is in downward direction, then the resultant displacement will be y1 minus y2. So this theorem is known as superposition theorem, and we have to understand this concept in order to learn or in order to understand the concept of interference. Okay. Now let us see what is superposition of waves. Now as we learned the superposition theorem, if a medium is if more than 2 or 3 waves are propagating in the medium, then different phenomena will occur depending on the nature of the waves. So according to superposition of two waves, consider when we have stationary wave, when we have beats, or when we have interference. When two waves, progressive waves, are traveling in medium in same direction and have same frequency, when two progressive waves are traveling in a medium having same frequency, traveling in same direction, superimpose each other, and in the region of superposition, the resultant intensity will be vary. The resultant intensity will be different from the intensities of individual waves. This phenomena is called interference. If we have two waves having nearly equal frequency, suppose if a wave is having some n1 frequency and other wave is having n2 frequency, which are nearly equal, the difference is very less. Then if these two waves are traveling in the medium in same direction, and after superposition they produce beats. So in some region the intensity of the sound is more. There are some regions where the intensity of the sound is less. The region or the phenomenon where the intensity is increased, the intensity of the sound is increased, is called waxing, and decrease in intensity of sound wave is called waning. One waxing and one waning contribute one beat. The number of beats produced per second is called beats frequency. So when two waves having same frequency traveling in same direction superimpose each other to produce interference, when two waves having nearly equal frequency traveling in same direction superimpose each other to produce beats. Then the third case is when two waves having same frequency are traveling in opposite direction. When waves are traveling in opposite direction, then they superimpose each other to produce stationary waves. So as You people know the concept of stationary waves in your lower classes. So when a string is tied at the both ends and plucked at the middle, then the string will produce stationary wave pattern, and we observe nodes and antinodes in the strings. It is known to you. Okay. So the superposition of waves leads three phenomena. One is interference, other one is beats, and the last one is stationary. Here we have different cases. In first case, we have same frequency, waves with same frequency traveling in same direction. In second case, we have two waves of nearly equal frequency traveling in same direction. And in third case, we have waves with same frequency traveling in opposite direction. Okay. Now, what is interference of light? So the interference, as we discussed, is nothing but when two light waves superimpose each other. Then in the region of superposition, the resultant intensity or amplitude is different from the intensity of individual waves. If first wave is having some intensity I1, second wave is having intensity I2, then in the region of superposition, the resultant intensity will be different. It is different from I1 or it is different from I2. Thus, the modification in the distribution of intensity in the region of superposition is called interference. Simply, if anybody asks you what is interference, then in single line, we can explain interference as the modification in distribution of intensity in the region of superposition. This is called interference. If the resultant amplitude is sum of the amplitudes of the individual waves, then it is called constructive interference. If the resultant amplitude is equal to the difference of the amplitudes of the individual waves, then it is called destructive interference. So in order to understand what is constructive interference and what is destructive interference, let us see the picture. Yeah, this one. Now I have two waves. Both are having same frequency, traveling in same direction. Here, it is clearly visible that the crest of first wave falls on the crest of another wave. The trough of first wave falls on the trough of the second wave. When crest of one wave falls on crest of another wave, or the trough of one wave falls on the trough of another wave, the amplitude increases. If this is Y1 and this is Y2, okay, if this is Y1 and this is Y1 and this is Y2, then the resultant displacement will be Y1 plus Y2. Resultant displacement will be Y1 plus Y2. This means when the crest of one wave falls on crest of another wave, or trough of one wave falls on trough of another wave, the amplitude of the resultant wave increases. If amplitude increases, as we know, intensity is proportional to square of the amplitude. Therefore, intensity rises here, intensity increases here. Then this is called constructive interference. Now see the second case, where the crest falls on trough of another wave, the trough falls on crest of another wave. In this case, the first wave is having displacement Y1, the second wave is having displacement in opposite direction Y2, therefore the resultant displacement is Y1 minus Y2. If amplitude is same, if it is A, this is minus A minus A is 0, or this is Y and this is minus Y, therefore Y minus Y is 0, therefore displacement is 0, or the amplitude is 0, therefore intensity is 0. So here intensity is Y1 plus Y2, here intensity is Y1 minus Y2, If both y1 and y2 are same, the here intensity is 0. This is called destructive interference. Hence, the waves having same frequency are traveling in same direction, superimpose each other. In the region of superposition, what we have observed is there are some places where the intensity is maximum. That is, the crest of one wave falls on the crest of another wave. Then the intensity at that point is maximum. There are some regions or there are some places where the intensity is minimum. That is, the crest of one wave falls on the trough of another wave. Crest of one wave falls on the trough of another wave. Therefore, the amplitude is decreased or the displacement is decreased. Hence, the intensity is decreased. If the amplitudes are same, then intensity will be minimum and intensity will be 0. Then the place is called destructive interference. Okay. So, in the present class, what we have learned is what is meant by superposition principle and what are the consequences of superposition of two waves, different conditions, and what is meant by interference, what is constructive interference and what is destructive interference. Okay, I think by listening to this class, you are able to answer what is interference, what is superposition theorem, and what is constructive interference and what is destructive interference. Thank you for patience listening.